Okay, so we have already seen two cases. The first case was XU less than DF, and in the second case we have seen XU is greater than DF and DF is less than 3. Know that this 3 by 7 XU, so it is convenient to remember like this. So in some textbooks you can find in the other way around also. So whichever you feel convenient. But for this is more convenient because we know that this is the stress block 3 by 7 XU and 4 by 7 XU. So now we have also seen this under info section, if I'm not wrong. ये हो गया ना?
No, sir.
Okay, okay. Okay, so this we had seen for a balance section, correct? So now for an under info section, so how will you find out XU? By equating CU equal to TU. Okay, so this is nothing but CU1 plus CU2 equal to TU, 0.36 FCK BW into XU, and this is 0.446 FCK BF minus BW into DF, and TU is 0.87 FY into AST. Okay, others please mute yourself, everyone. Okay, so this is how you are going to find out your XU. Now, after finding out XU, what you will do? You will first check whether this condition is satisfying or not. First, you will check XU is greater than DF or not. You already have the value of DF with you. You will find out XU and then you can check the condition whether XU is greater than DF. Then what you will check? You will check whether this second condition is also getting satisfied or not. What is the second condition? DF is less than 3 by 7 XU. तो वो भी check करेंगे DF is whether it is less than or not. It is less than 3 by 7 XU or not. And then we will, as usual, we check XU should be less than XU max. So once you check all these three conditions are satisfied, then the assumption is correct and it is an under info section. If all these three conditions are satisfied, then the assumption is correct and it is an under info section. Is this clear? And then you can actually find out the moment of resistance. Okay, if either of these conditions are not correct, then you have to change the assumption. Then MR is given by what? CU1 into lever arm 1 plus CU2 into lever arm 2. So 0.36 FCK BW into XU into lever arm plus second area के लिए 0.446 FCK BF minus BW into DF into D minus DF by 2. I hope this is clear for an under info section. Yes or no?
Yes, sir.
Okay. So now let us move on to the third case. Again, very interesting case. The third case is nothing but your XU is greater than DF and DF is greater than 3 by 7 XU. Okay, so this is the third case. So let us understand this third case. So XU is greater than DF. Here you can see this is total my XU. It is greater than DF, no doubt. Then DF is greater than 3 by 7 XU. This is DF. अभी देखो 3 by 7 XU DF से छोटा है. That means DF is greater than 3 by 7 XU. Can you see my cursor, everyone?
Yes, sir.
So this is 3 by 7 XU is less than DF, or you can say DF is greater than 3 by 7 XU. So in this case, how are we going to analyze? So that is what we are going to see. So this is the stress diagram. So now again I have differentiated this into area 1 and area 2, web area and the flange area. So now this diagram is for stress area 1. Okay, this diagram here you can see CU1 will act at 0.42 XU max and lever arm distance is nothing but D minus 0.42 XU. Now coming on to the actual stress for area 2. ठीक है, second के लिए this is DF, ये total DF है इधर से लेकर इधर तक. But now since this is a combination of a rectangular and a parabola, are you getting? तो इसका अभी CG निकालना पड़ेगा, करेक्ट, सेकेंड एरिया के लिए, because we want to find out the location of CU2 also and its corresponding CG. So what IS code has recommended equivalent rectangular stress diagram for area 2. Since area 2, now इसका again analysis करना पड़ेगा दो area के लिए. So for convenience, for simplicity, what IS code has done, IS code has done given an equivalent rectangular stress diagram for this area. ठीक है, सो इसको वापस पूरा सेपरेट करने से बेटर एक कंप्लीट रेक्टेंगुलर एज्यूम किया और उसमें सेंटर पे एक्ट करेगा द सेकंड फोर्स. आर यू गेटिंग? एंड लेट अस से दैट इज Cu2 or YF. So this is as per IS 456, and the distance from the top compression fiber will be YF by 2. Okay, so that is the only
सर वो
difference here.
डायग्राम में कुछ दिख नहीं रहा है.
Yes, come again.
सर दिख नहीं रहा है डायग्राम में.
Okay, just I'll just okay. Now is it clear? ठीक है, whatever the terms are, I will tell you. Don't worry. I hope this is visible. ठीक है, ये जो है just a second. ठीक है, so this is the actual stress diagram for area 2. ठीक है, ये था area 1. ठीक है, ये तो तुम्हारा combined था. ठीक है, this separate किया है मैंने for area 1 Cu1 और area 2. ठीक है, दिस इज द एक्चुअल स्ट्रेस फॉर एरिया 2, ये वाला फिगर. और दिस इज फॉर एरिया 1. नाउ दिस इज द इक्विवेलेंट रेक्टेंगुलर स्ट्रेस डायग्राम फॉर एरिया 2. ठीक है, एरिया 2 के लिए अभी मैंने बताया. अगेन दिस इज कॉम्प्लिकेटेड. टू सिंप्लीफाई दिस, IS कोड हैज रिकमेंडेड दिस. ठीक है, व्हाट इज YF? वी विल सी. YF इज गिवन बाय 0.15 XU. ठीक है, सो below also I have written, don't worry. So just understand this figure. ये figure clear है सबको? What I've explained so far. ठीक है, since the condition is DF is greater than 3/7 XU, तो in this case this is the issue. To simplify this, IS has recommended this. तो सेंटर पे एक रेक्टेंगुलर ब्लॉक कंसिडर किया, स्ट्रेस ब्लॉक, एंड उसका सेंटर पे एक्ट करेगा फोर्स YF/2. I hope this is clear. So now let us see, for a balanced section what will be MR? Cu1 into lever arm 1 plus Cu2 into lever arm 2. Cu1 तो सेम ही रहेगा. ठीक है, सो दिस विल बी XU max एक्चुअली 0.36 FC के BW into XU max D minus 0.42 XU max प्लस सेकेंड फोर्स इंटू लीवर आर्म 0.446 FC के BF minus BW into जो DF होता था उसके जगह पे अभी क्या आ जाएगा? YF. दिस इज द ओनली डिफरेंस, यू हैव टू रिमेंबर दिस. ठीक है, DF के जगह पे अभी मैंने जो बताया एक्सप्लेनेशन, IS हैज रिकमेंडेड YF. तो वो जो रेक्टेंगुलर जो ब्लॉक एज्यूम किया है उसका जो डेप्थ है YF है, और लीवर आर्म क्या हो जाएगा? D माइनस YF/2. इफ यू सी दिस फिगर, ये टोटल YF कंसिडर किया है, ये रेक्टेंगुलर है, पे अटेंशन. ये जो है ये पूरा रेक्टेंगुलर है, और ये जो है रेक्टेंगुलर प्लस पैराबोलिक है. तो ये जो टोटल है इसको YF कंसिडर किया है डेप्थ को, और जो सेंटर पे Cu2 एक्ट करेगा वो YF/2 पे एक्ट करेगा. तो इसको एकदम सिंप्लीफाई कर दिया IS कोड ने. इज दिस क्लियर एवरीवन? सो इन दिस इक्वेशन जो थर्ड केस में द ओनली डिफरेंस इज YF, DF के जगह पे YF आ जाएगा. नाउ YF का वैल्यू भी दिया है IS कोड ने, सो दिस यू हैव टू रिमेंबर 0.15 XU plus 0.65 DF. Okay, so YF is given by 0.15 XU plus 0.65 DF. ठीक है, अंडर इन्फो सेक्शन के लिए क्या हो जाएगा? फर्स्ट XU कैसे फाइंड आउट करेंगे? अगेन Cu1 plus Cu2 इक्वल टू TU. 0.36 FC के BW into XU plus 0.446 FC के BF minus BW into YF is equal to TU will remain the same. Sorry. ठीक है, सो नाउ इन दिस केस व्हाट यू विल चेक? सबसे पहले XU ग्रेटर देन DF है कि नहीं, दैट वी विल चेक. एंड देन DF is greater than 3/7 XU, and the last is XU should be less than XU max. If all the three conditions are satisfied, then the assumption is correct and it is an under enforced section. Then you can proceed and find out the moment of resistance. Is this clear, everyone? So now let us see इसका MR का इक्वेशन क्या हो जाएगा. ठीक है, इसका MR का इक्वेशन सिंपल अगेन. MR is given by CU1 into lever arm 1 plus CU2 into lever arm 2. So 0.36 FCK BW into XU into D minus 0.42 XU plus 0.446 FCK BF minus BW into YF. ठीक है, into D minus YF by 2. तो सेकंड केस और थर्ड केस का सेम ही है. द ओनली डिफरेंस इज in place of DF it will be YF, and YF is given by what? 0.15 XU plus 0.65 DF. Is this clear, everyone?
Yes, sir.
Okay, fine. So now with this knowledge we can actually start with the numericals. So equations, if you want to please make a note of the equation just, then we'll start with the numericals. Okay, so shall we start with the numericals now, everyone? Yes, am I audible?
Yes.
Okay, so let us start with the numerical. The first numerical, take down the question. Calculate the moment of resistance of a singly reinforced T section having the following details. Calculate
So
the
can you repeat?
yes. Calculate the moment of resistance of a singly reinforced T section having the following details. So in that write down BF.
Sir, can you repeat slowly?
hmm, Calculate the amount, sorry, the moment of resistance. Calculate the moment of resistance of a singly reinforced T section, having the following details. BF equal to 1200 mm. ठीक है, so BF is 1200 mm. DF is 150 mm. DF means depth of the flange. DF is 150 mm and BW is 300 mm. And BW is 300 mm. Effective depth is 600 mm. Effective depth is 600 mm. The section is reinforced with 3 bars of 20 dia. The section is reinforced with 3 bars of 20 dia. Consider M20 and Fe415. consider M20 and Fe415. That is the question. Yes, everyone got the question. So what is given? I will just draw the figure. ठीक है, सो दिस इज द टी बीम. अभी मुझे बताओ विड्थ ऑफ द फ्लैंज ये वैल्यू कितना है? यस ऑल ऑफ यू.
1200.
1200.
Correct. So this is 1200. Now tell me what is the depth of the flange? This value.
150.
This is 150. Now what else is given? Width of the web दिया है, मतलब ये है मेरा width of the web. ये कितना है?
300.
300. What else is given?
Effective depth.
हाँ, effective depth is given to us, and also the AST is also given. So AST is nothing but 3 bars of 20, I think. Yes, 3 bars of 20. So effective depth will be from this. So effective depth is how much?
600.
Yes. So this is your figure for the T beam. Okay. So now what is asked in the question? It is asked to find out moment of resistance. So basically we have to find out moment of resistance. So how will you find out the moment of resistance? So we have seen all the three cases. So that means your XU you will find out either by any one of those cases. So in this, what, how to proceed in this T beams? First you will have to assume any one of those cases we have discussed. So first you will have to assume any one case and then proceed and find out the value of XU, and then check if it is satisfying the condition, then your assumption is correct, and then you can find out the MR. Okay, so first write down assume XU is less than DF and then find out the value of XU. ठीक है, तो सबसे पहले क्या करेंगे? assume XU is less than DF, and now we will find out the value of XU. Yes, quickly give me the value of XU now. How will you? This is our assumption, XU less than DF. So now we will equate CU equal to TU and find out XU. CU equal to TU. Correct? Give me the value of XU. What is the equation? Anyone? CU equal to TU. 0.36 FCK BF into XU equal to 0.87 FY into AST. Am I correct? So with the help of this equation, give me the value of XU. Yes, anyone got the value? Okay, Mahfouz is saying 39.38. Yes, anyone else? Just confirm this value. So therefore, XU, you will get a value. Yes, anyone else? So let me write this value. 39 point. Okay, Abdul Qayyam also is getting 39.38. Okay, fine. So we got the value of XU. So now tell me this XU जो assume हमने किया था वो assumption correct है? This XU, what is DF is 150, so this XU is certainly less than DF. Absolutely no doubt about that. This XU is less than DF. So what does this imply? So hence our assumption is correct. So you can write XU is less than DF. Hence, so you can write down. Hence our assumption is correct. And then we will find out what else we have to check apart from this. If you have listened carefully the theory lecture, और क्या चेक करना है इसके बाद? Yes, exactly. Whether it is an under info section or not.
XU
So
max.
now find out XU max. Now find out XU max. XU max for FE415 is given by what?
0.480.
0.48D.
Yes. So XU max is given by 0.48D. So now give me the value of XU max.
288.
Okay, so this is 288. So now from this we can say that therefore XU is less than XU max. So therefore XU is less than XU max. So hence the assumption is correct and it is an under reinforced section. So you can write hence it is an under reinforced section. So अपना assumption भी correct है and also it is an under reinforced section. So now you can find out MR. ठीक है? Now you can find out MR. So therefore MR is given by Cu into lever arm. So MR is given by Cu into lever arm. Give me the value of MR now quickly. Yes, anyone got the value of MR? Okay, Rohit 198.51. Okay, fine. So MR is 198.5. So that is the final value of the MR. Yes, I hope everyone got the answer. Is this clear, everyone? So understood how to proceed in case of T beams. Whenever it is asked to find out the MR, so first you have to assume any case, and then once it is the assumption is satisfied and it is an under info section, then you can proceed to find out the moment of resistance. Yes, I hope everyone got the answer of this. Okay, so shall we go for the next question? Yes or no?
Yes, sir.
Okay. So write down the second question, everyone. Calculate MR of a T section having the following details. Calculate the MR of a T section having the following details. The width of the flange is 1000 mm. The width of the flange is 1000 mm. The depth of the flange is 100 mm. The depth of the flange is 100 mm. The width of the web is 450 mm. The width of the web is 450, and the effective depth is 750. And the effective depth is 750. Consider M25 and FE500. Consider M25 and FE500. AST is equal to 6 bars of 25 dia. AST equal to 6 bars of 25 dia. That is the question. Okay, I hope everyone has got the question, got the data with them. So I have written here also. So the width of the flange is 1000, depth of the flange is 100, width of the web is 450, and overall depth effective depth is 750, and AST is 6 bars of 25. So now calculate the MR of this. Quickly give me the value. Okay, I think the last 10 minutes are remaining. So let us finish this problem. Give me the values. The procedure is the same. So first you will assume XU less than DF, and then you will check whether it is an under info section or not, and then you will find out the MR. So now in this case, so first let us assume XU is less than DF. So now give me the value of XU.
142.35.
XU is 142.35. Yes, what about others? Okay, XU is 142.
Yes, sir.
Does anyone just confirm this value? XU and XU max. Yes, anyone? XU का 142 है क्या value? So if XU is 142, just confirm this value. So what does this imply? This means that your XU is greater than DF. Correct? DF कितना है? 100 है. So that means our assumption is incorrect. So you can write, hence the assumption is incorrect. So in that case, you will have to assume the second case or the third case. So it is better that we assume the next case, that is XU is greater than DF and DF is less than 3 by 7 XU. So after this, write down, hence our assumption is incorrect. Yes, for the first case, I think XU is 118, not 142. Okay, just check your answer, Mehfooz. This is 118. So still it is 118 is greater than DF. So hence the assumption is incorrect. So now go for the next assumption or the next case. So what is the next case? Assume so now go for the next case. Assume XU is greater. Next case क्या है? Assume XU is greater than DF. XU is greater than DF and DF is less than 3 by 7 XU. DF is less than 3 by 7 XU. So now check for this case. So again, use the equation to find out XU. For this case, tell me, for this case, what is the equation to find out XU? For the second case, okay, we have already done this. So accordingly, you will use that equation and find out XU. Second case के लिए अभी XU find out करो, everyone. Second case के लिए find out XU. So the equation will be Cu1 plus Cu2 equal to Tu. I hope everyone is getting what I'm trying to say. Yes, anyone got the value of XU? You have to be a little bit quick now. Okay. So for the second case, you're getting 111, Rida and Abrar, both getting the same. Yes, what about others? Others are also getting 11111. Okay, fine.
Yes, sir.
So what does this imply now again? So what we have assumed, we have assumed that XU is greater than DF. तो XU कितना आया, 111 आया, so that means it is greater than DF. Now we have to check the second assumption. Second क्या है, DF less than 3/7 XU है कि नहीं, चेक करो. Which value is this, Rida? Second condition, is it satisfied? Just tell me. Okay, 3/7 XU is 47. So that means DF is 100. So 100 is not less than 45. So the second condition is not satisfied. So what you will do now? You will go for the third condition. As simple as that. Correct? So now what is the third condition? The third case is, let me write here. The third case is XU greater than DF and DF greater than 3/7 XU. Am I correct? So go for the third condition now. The third condition is XU is greater than DF and DF is greater than 3/7 XU. So now again find out XU and then check and then let me know.